The final presentation from TERA. My name is TERA. TERA consists of Farrell and Alabama and Rajesh Johan. She is trying to address the problem where health professionals are lacking access to pricing information when providing medications to the patients. Without this information, the clinician is lacking detail to better the patient's financial needs. Understanding the price of generic versus brand name allows the clinician and patient to work together to address this issue. Currently, there are a few options that accomplish this goal. UHG is looking to break into this space by leveraging cutting-edge technology. The goal of our project is to allow a clinician to get immediate pricing information when prescribing a medication through an EHR. This is achieved by leveraging CDS hooks. These hooks provide contextual information about the actions taking place within the EHR. In our case, it is the medication prescribed. High level, the EHR will generate a request containing patient and medication information. Our server will then parse this information and call our pricing provider. Our service will then aggregate this information into a card object that is returned to the EHR. That card is presented to the clinician. Our CDS service provides a discovery URL and supports a price check. When finding pricing information, we use GoodRx. GoodRx is a service that tracks prescription drug prices and makes them available to the general public. For a given drug name, GoodRx will return a list of prices that are available in your area, as well as generic alternatives for that drug. Available also is fine-grained information about dosing and quantity. This enables the consumer to make an informed decision about what drug to purchase and where to purchase it. Our service will return to the user the best price for the generic and brand name drug and the pharmacy that is available at. We leverage existing Fire server for patient information. As you can see in the screenshot below, a generic to Tylenol is available at Kroger Pharmacy for $2.19, which is a savings of $5.33 over the brand name. Our goal is for this text to be easily understood and the actions clearly defined within the card. From start to finish, our project had a number of challenges. Initially, UHG wanted us to work with Epic EHR platform. However, this turned out to not be possible because Epic denied us and UHG a developer account for their Orchard platform. As a result of this, we had several discussions with UHG and ultimately decided to pivot the project to not have EHR integration. Initially, UHG wanted to use OptumRx for prescription drug pricing information. However, there were internal issues with granting us access to their database. To replace OptumRx, UHG made the decision to go with GoodRx. We requested an API key to use their APIs. However, we received no response even after UHG became involved. Despite this, we were able to get information from GoodRx through other means. To do so, we simulate navigating to their page and scrape the return JSON object to get the pricing information. This solution was the only viable method to get pricing results within the project timeframe. However, this does have its limitations as it will not work if GoodRx's response changes. For a CDS hook implementation, a discovery endpoint listing implemented hooks is required. We support discovery and currently return price check as our supported hook. The price check hook will be called from the EHR platform via a trigger, such as a medication prescribed. All request response objects utilize the CDS standard JSON format. The screenshot below contains a brief snippet of the returned object for a price check request. In order to test our service, we utilize the CDS Hook sandbox available at cds-hooks.org. This provides a visual front end and lets you specify an arbitrary Fire and CDS service. Through this front end, we can specify an arbitrary medication and have our back-end service called with it to do the price check. Our service is wrapped in a Docker container so it can easily be deployed anywhere. Our server is written entirely in Java, utilizing the Spring framework for web service capabilities. It is currently publicly accessible and hosted on HDAP, but we could easily run it anywhere. Our code can be built through Jenkins, or it can be built locally via command line or an IDE. Looking to the future, we wanted to also get prices from Blink Health and display them alongside GoodRx's prices. However, this was not possible in the given time frame. We would like to have also integrated with a Fire server to return potential drug interactions with the proposed drug. Finally, once we got access to an EHR, we would like to actually change the medication order based on the clinician's response to our card. This is our final Gantt chart showing the progress throughout the semester. We were able to follow through on everything except the parts related to Epic integration. Preparing for our final submission, we documented our deliverable, validated our code compiles, and made sure that our Docker container works properly. The full Gantt chart is available at the provided link.